Module 2, Digital to Digital Conversion. In this module, we are going to discuss is about the conversion from digital to digital. When already the data is in digital, why should we convert again into digital? Here the first digital represents data, whereas in the second digital represents signals. So basically, what is the data? Data is nothing but it is a small piece of information. It is a small piece of information we are going to send or receive. This data can be in two forms. Either it can be in terms of digital or it can be analog. What is digital? Digital means the data will be represented in terms of bits, either in zeros and ones. Whereas in analog, we do it in terms of continuous waves will send, that is analog. Analog means continuous, whereas digital is discrete. So the data can be either digital or analog. Signals what we represent, that also can be digital or analog. Analog means you can consider as sine wave and any waves like sine wave, cosine wave, whereas digital waves it is in terms of square waves. Okay, now what we can do is we have to send or we have to convert the digital data to the digital signals. That is, the digital data has to be carried out from sender to receiver in digital signal mode only. For that purpose, we have three techniques. One is line coding, second one is block coding, third one is scrambling. Line coding is very much important, whereas block coding and scrambling may or may not be required. Now let us see what is line coding. Basically, what is coding? Coding is a process of converting digital data to digital signals, because here we need digital to digital, whereas there is a case where you have to convert analog to digital also. The first point you have to remember in digital to digital conversion is stream of bits will be converted into square waves. First thing is data, second digital is wave. Stream of bits will be converted into square wave. And here in line coding, what actually the data can be of any form, right? It can be text, audio, video, numbers, image, graphical image, and so on. Whatever the data it is in whichever the form, we have to convert them into sequence of bits, and that sequence of bits has to be carried out through the digital signal, that we call it as line coding. Line coding converts a sequence of bits to a digital signal. At the sender, encoding process will take place. What is encoding? Encoding, we encrypt the data such that it is not hacked by someone or not modified. Okay, whereas in receiver side the data again it will be decoded, means bring it to the original form and see. Okay, so figure 4.1 shows the process. Later we will see that figure. Now let us see the characteristics of this line coding technique. Okay, first thing is signal element versus data element. Second one is data rate versus signal rate. Third one is bandwidth. Fourth one is baseline mandering. Fifth one is DC component. Sixth one is self synchronization. Seventh one is built-in error detection. Eighth one is immunity to noise and interface. Ninth one is complexity. All the 9 characteristics are required. Let us study one by one. First one is signal element versus data element. One thing we have to remember is what is data. Data is a smallest entity. It is a piece of information is called data. Whereas what is a signal? Signal is signal element is the shortest unit of a digital signal. In other words, to keep in mind, you can think as data element is what we need to send. See, for example, I need to send the whole module into 10 minutes itself I have to send. But is it possible? The signal elements can take only the limited amount of data, means I have to wait only. So data is a small entity that can be represented as a piece of information, whereas signal element is the shortest unit of a digital signal. Now we have to find the ratio such that how many data is sent per signal. For one signal, how many data we can send. Okay, we'll take the cases. Here the ratio R represents number of data elements carried by each signal element. For one signal element, how many data can be carried out? We have different cases. See case 1. One signal, one data element. Okay, one signal, one data element. We can see to that here this is one signal, here one signal, and here one signal, right? Here we have 3 signals and 3 data are there, 1, 0, 1. See, this is the limit. These dotted lines are the limit. Under one signal we carry out 1 bit of data element. So one data element is carried out per one signal. Therefore R is equal to 1 by 1. Why? Because data element, what is the ratio? Ratio is nothing but number of data elements carried out by each signal. Data elements by signal element, right? Data is 1 data, 1 signal. So 1 by 1 is 1. R is equal to 1. In case 2, I need 1 data element, 2 signal elements. Okay, for I need 2 signals to send 1 data. To send this bit 1, 2 signals are required. Then what will be the ratio? Ratio is what? Number of data elements by signal element, right? Data element is 1, and how many signals you need to send this 1 bit? You need 2 signals. That is what they have represented. See in black code. Okay, so this 2 signals, if I send only, this 1 will be conveyed to the receiver. So it is R is equal to 1 data element divided by 2 signals. Therefore R is equal to 1 by 2. In third case, let us see 2 data elements in one signal. Only in one signal itself, if I can send 2 datas, then what will be your ratio? Data by signal, right? So 2 by 1, that is nothing but R is equal to 2. Case 4. 4 data elements, 3 signal elements. To send 1101, this is our data. To send this data, I need 3 signals, means what is the formula? R is equal to data elements by signal element, right? So data is 4. Data is 4, signal is 3, therefore R is equal to 4 by 3. This formula you should remember. Where is this formula? R is equal to number of data elements carried out by each signal element. The first concept, the characteristic what today we discussed is about signal element versus data element. What is signal element and what is data element? First point, you should know what is the difference. Secondly, how many data is carried out per signal, that also you should remember. Okay. Now let us discuss the second one, data rate versus signal rate. Here firstly, rate means whenever the term rate comes, automatically one thing should come to our mind is time. Based on time only we speak about rate. Data rate, signal rate. Data rate, name itself says data rate means number of data that you can send per second. In terms of seconds we will be discussing. So the number of data elements that you can send per second is called data rate. Whereas what is signal rate? Number of signal elements that you can send in per second. Per second is in what? In 1 second, how many signal elements you can send, then that is called as a signal rate. The data rate defines the number of data elements. What is your data elements here? Bits, right? Bits sent in 1 second. The unit is bits per second. For data rate, the unit is bits per second. We represent it as BPS. Whereas in signal rate, the unit is baud. Signal rate is number of signals element sent in 1 second. In terms of per second, we will discuss. What is data rate means? Number of data elements that is sent in 1 second is called data rate. Number of signal elements that is sent in 1 second is called as a signal rate. And the unit for data rate is bits per second, whereas in the unit for signal rate is baud.